Uh, so I'm really excited to be here. Am I loud enough for the back of the room? Uh, my talk's gonna cover some things that we talked about Solid, and I was kind of playing devil's advocate, Josh. I didn't mean to be hard on Solid. I really respect uh, uh, the concepts, decentralizing the web. So my talk's called "The Emotion of Things: uh, Nurturing Talking Machines," and really it's about first, my journey into computing from being a poker player, uh, and about natural language processing, present and future, especially synthetic data and edge computing, uh, about the significance of media, of society, and the value of data. And ultimately, I'm creating a kind of competitive open source broadcasting platform that's called Blockstar. So I'll talk about that at the end as well. Uh, so computational cinematography, what does that phrase mean? I mean, you heard the words, you recognize them. What does it mean? Before I ever got into computational intelligence, I was a professional poker player. At 15 in 2017, I started playing online, and like most serious online players, I use statistical methods and a heads-up display to inform my decisions to bet, raise, call, or fold, something kind of like this. And then in 2011, online poker was made illegal inside the United States, so I quit. And in 2012, I moved to New York City. At nights, I worked as a server in fine dining restaurants, which was a struggle for a working class introverted nerd with no prior experience in formal dining culture. And after my work would finish around midnight, I went to play underground poker games, to play Hold'em with businessmen, advertisers, real estate investors, restaurateurs, journalists, finance types, guys not too different from those who I just finished serving. And online, it's conceivable to play up to 24 tables at a time at 60 hands per hour. And you can observe tables without playing or buy data sets from other people. But live poker is slow. It takes it takes thousands of hours for a player's tendencies to converge statistically. But at 20 hands per hour, limited to one table at a time, to be successful playing live poker, you can't limit yourself to statistics. You have to be much more psychological in your reasoning. And quickly, my poker strategy evolved. I learned to consider the emotional dynamics of my opponents and the table as a whole. At first, I tried to study people's facial for tell. It didn't work as well as in the movies. But I found that body language conveyed a more significant signal than facial expressions. And my game really improved when I started to listen. As an online player, my perspective on emotion was to prevent emotions from clouding my decision making. And as a live player and as a server, I learned to care about the emotions of others. And I became sensitive to my own emotions, no longer something to avoid. My emotional experience was key to my decisions. I discovered intuition. Poker is a game of deception. Everyone is lying always. When someone's bluffing, they will act and sound strong. When they have the winning hand, they'll play weak, or they may go up a level and play like they're playing weak, or go up another level and play like they're playing weak, and so on. But liars always have a motive, and if you listen closely, you can hear it in their voice. Only trained experts can lie without wavering in the tone, timbre, timing, and volume of their voice. The speaker's motivation leaks out if you listen. To listen to the emotional cues that convey the intentions of the speaker, to go beyond the literal meanings and definitions of words and phrases, or their embedding in context, to pay attention to the depth of our desire. That's where AI is destined. So how did I get into AI? Well, in 2014, I loved listening to the Thinking Poker podcast, even more than I like playing cards. And it was then that I was introduced to neural networks because, bots started beating the best poker players. So I had this transition from really a totally math-driven strategy to being much more considerate of psychology and to see emotion, especially to hear it in people's voices, and also read faces and bodies. But becoming a deep listener really kind of changed my life, I would say. So the the core of this talk and what I'm thinking about right now is artificial intelligence, and especially natural language processing, speech recognition, speech synthesis, understanding, and translation. So to learn language from humans, machines must listen to and generate human language, right? And that means that we need to have massive amounts of speech data. But collecting a lot of data brings up ethical concerns around privacy and security. So to me, general intelligence for machines is about understanding emotions. And really, emotional intelligence is empathy. So once again, ethical data collection is key. If the machines start off, violating human norms, that's really not that doesn't bode well. So empathetic machines can learn complex tasks by imitating humans. So embodied AI robotics will advance really through listening. But the state of the art in speech recognition isn't quite there yet. Descript, that does some speech recognition software online, did a ranking of online speech recognition APIs, and this was in like November or September 2018, just a few months ago, and the best one is 16% error per word. That's kind of a flawed measure because some words matter more than others. And YouTube has a much better closed captioning system than what Google's API lets developers use. But still, what if speech recognition worked flawlessly? I hope this video sound plays.
Most excited about in terms of directions of artificial intelligence at this moment?
So, forgive me, this is Dr. Lex Friedman. He's a research scientist here at MIT studying artificial general intelligence. And he's asking this question: what are you most excited about in terms of directions of artificial intelligence in the next few years? To Dr. Jürgen Schmidhuber, co-director of the Dalmol Institute of Artificial Intelligence Research. And he's one of the innovators of some significant speech recognition neural network architectures, like the long short-term memory system used for most translation systems.
Are you most excited in terms of directions of artificial intelligence at this moment in the next few years in your own research and in the broader community?
So I think in the not so distant future, we will have for the first time little robots that learn like kids. I will be able to say to the robot, look here, robot, we are going to assemble a smartphone. Let's take this slab of plastic and the screwdriver and let's screw in the screw like that. No, not like that, like that. Not like that, like that. And I don't have a data glove or something. He will see me and he will hear me and he will try to do something with his own actuators, which will be really different from mine, but he will understand the difference and will learn to imitate me, but not in the supervised way, where a teacher is giving target signals for all his muscles all the time. No, by doing this high-level imitation, where he first has to learn to imitate me, and then to interpret these additional noises coming from my mouth as helpful signals to do that better. And then it will, by itself, come up with faster ways and more efficient ways of doing the same thing.
So to go from the current world into the future that Dr. Schmidhuber is discussing will take some kind of breakthrough. And maybe that will just be faster computation or more data or more likely better algorithms. So progress in terms of compute power is all about either application-specific independent integrated circuits, like the TPU that Google makes, specifically for their TensorFlow machine learning framework, which is somewhere between 30 and 80 times more energy efficient than a GPU. Or perhaps it's through using, whoops. Hope the video comes back. FPGAs are also really exciting because you can design custom hardware architectures, and there could be some efficiencies to that. Once you deploy them, you can reprogram them as you think of a better architecture. Unfortunately, programming FPGAs is hard. It requires a deep understanding of machine logic. The upside, once again, is the energy efficiency, maybe 30 times better than a GPU. And it's the high energy efficiency that enables edge computing. Edge computing is bringing the computers to the data, as opposed to sending the data up to the computers. Why do you want to do that? Well, your connectivity to the cloud might be unreliable or slow. Maybe you're collecting massive amounts of data, or because you care about the security and privacy of the users, and the cloud can jeopardize that. Some of the most significant applications of edge computing are going to come with autonomous cars. That's in the short term. Yeah. AWS, I guess.
No, just saying edge computing is computing.
Yeah.
If we drop that stupid word edge.
Well, it's important to talk about, especially in the context of speech recognition, because there's like no good speech recognition software that you can just plug into your laptop, or
No,
like.
I understand you. Someplace, it's just understandably, we somehow created.
Okay. So maybe a better term is
You seem to know about graph theory. It really refers to where it falls on the.
No, I understand. No, I understand. Well, I'm just saying.
Larger topology of the network.
No, I understand what you're saying.
a better term might be, for some context anyway, like supercomputing locally, right? So if you're doing an autonomous car, you probably want to have a voice interface for navigation and entertainment. That's really going to be a thing. And if it's a luxury car, then the privacy and security is crucial. If you're thinking about advanced robotics, well, the downside was that it listened to everything that I said and it advanced their AI with it. So yeah. I'm really with you. I hope I'm not coming off as like anti-privacy, because I like privacy.
Just giving you grief. Keep going.
So, and if we think about more advanced robotic applications, then a really low latency response can be valuable. And in industrial applications, there could be harsh conditions that limit the network connectivity. Then if you think about like caregiving medical robots, then the privacy and security concerns aren't just about the experience or the well-being of people, but there's a legal side to it as well. So, advances in speech technology could come from just collecting more data. And to do that, maybe you'd sell a data machine, you know, some device that just listens all the time, but it should only listen after hearing a wake word. The people who buy those devices trust the manufacturers, have integrity or, you know, long-term reputational incentives. There's kind of like a race to build these systems. So, you know, who knows what's going on? A promising alternative to harvesting mass amounts of data is generating synthetic data. And this is an approach that's applied successfully to learning features and objects in images, for instance. But there's limits to the insights that you can draw from image processing. Here's another clip where Dr. Friedman interviews Dr. Lisa Barrett. She's a professor of psychology at Northeastern, the author of How Emotions Are Made. Yeah.
So what's our bottom emotion for folks that haven't considered, have only considered emotions at a surface level?
I would say one common misconception is that you can look at someone's face and read their emotion the way you read words on a page. That everyone around the world, when they're feeling angry, they scowl. When they're feeling happy, they smile. When they're feeling sad, that they frown. The way that I'm saying it sounds preposterous, and it is preposterous, but unfortunately, that is actually what a lot of people believe. And tech companies around the world spend tremendous amounts of money and, you know, in the investment of some of the most creative people on this planet trying to build emotion detection systems, when really what they're building are excellent systems for reading facial movements, which have no intrinsic emotional meaning. I mean, sometimes facial movements communicate emotion, but many times they don't.
So really, to make better natural language computation systems, we need better algorithms. So just thinking more about the, you know, generating synthetic data, NVIDIA and Google have demonstrated some powerful generative adversarial networks. So these are some images that are made of people who don't exist, but they look pretty real. And the key to, you know, creating fake things that seem real, that we know thus far, is not just to be generating stuff, but also to have some notion of critique, where you can weed out the things that aren't so good. But given these techniques, why isn't human-level speech synthesis already solved? It's because audio is really complex. It's deeper than video. I mean, for many videos, the soundtrack is most of the meaningful content for a fraction of the file size. Not just contains literal meaning, but it also has the depth of emotion to it. And emotional computation systems are still in their infancy. Audio. But perhaps it's just inherent that, like, in audio, in sound, in speech, there's just more opportunity to convey ideas. I mean, even if you compare sound to text, there's humor and rhythm and intonation and wordplay and regional or subcultural accents. You can perform or impersonate somebody else, or you can stutter and have deformed phonemes or disfluencies. You like to simplify. So, given all the data and computation in the world, the barrier to high fidelity speech computation is algorithmic. So how do we invent or discover those algorithms? It's likely going to take jumping outside the box of the current neural network programming paradigm. And neuroevolution is one way to do that. And I guess what I mean by evolution is that you have some agents in an environment competing for limited resources. And I think of evolution in a broader sense than just biology. Like a culture can really evolve. If you think about human beings in a grand scale, we really are organisms that can talk. And it is speech that really defines humans compared to other animals. And that comes about, 50, 100,000 years ago. The limit of speech is that one person can yell at a few thousand people in an amphitheater if they can get the other people's attention for long enough. When writing's invented, now ideas are portable across space-time. But initially, most of the people who can read and write are government officials or religious scholars. And it takes print for writing to become democratized. The cheap reproducibility of text stimulates demand for literacy and creates a kind of public intellectual commons. And then broadcasting makes mass media accessible to people who are illiterate. But it's one directional. You really need the government's permission to be a broadcaster. And we talked about like licensing for frequency just a few minutes ago. When social media comes out, now anybody with the internet can broadcast. And there's this explosion of creativity. There's some problems that come with that as well. Really, I'm thinking about, I call it, not just me, it's called generative media. So anything connected to the internet can broadcast and anything can listen. And in the short term, this could kind of amplify some of the social media chaos. We've already seen some things like the bot named Tay, or Norman, the world's first psychopath AI from the MIT Media Lab. Bad news isn't a new problem, but the upside is that in the not so distant future, we will have some technologies where you could have a script written by a human or an algorithm that is transformed into a feature film or like 1,000 films without a camera. So AI is going to become how do we get there? It's by making language more into a game, because computers are good at games. More Wittgenstein.
In the sense that language is rather than a system of rules of how you form words and phrases, etc., or as there are people and somebody does some action and that action is by another person interprets that, then derives some information from it, and that's where you get where sort of systematic approach to language for certain things in natural language kind of difficult to explain as reasonable in certain language, and much easier to, for example, if some people say, let's go hang out by the river dried up 10 years ago, they still go to a place that they call the river that used to be the river, no longer the river. In systematic perspective, language game that is the river, because the river they all know is that location.
You hit it right on the money, yeah. Yeah, I didn't expect everybody in the audience to really be up on the linguistics or philosophy or stuff. Not that I'm an expert either, but yeah, I mean, the way to get computational language processing systems to advance is for them to get less formal. For grammar to not be defined, but to be yeah, and then to constantly be reinvented as well. Like, think of Steve Jobs with the Apple ad, think different. That's not grammatical, but it's actually more meaningful. And so a game is competitive. A language game or competitive broadcasting, in some ways it's a game of attention, where, say, a podcast that's translated by a machine is subject to evaluation by humans and other algorithms, and is then ranked, scored, and there's a leaderboard. And all of the generator or discriminator or critic algorithms, they are competing basically for survival. So when this system emerges, it's going to be massively valuable. As of 2017, The Economist was already saying that data is the world's most valuable resource. But in commodities, the refined essence is worth much more than the raw, crude product. So right now on social media, many people are kind of live streamers or live bloggers, or they just say like everything that they're doing, and it's mostly meaningless. But really the value of the human and algorithmic part of online networks is about that process of filtering, of getting the signal from the noise. All of this is a preamble, for me to talk just briefly about what I'm building called Blockstar. It's a podcast production, distribution, discovery, and review app. Really meant for humans and bots to work together, where every interaction that you have with the app is a transaction, because the algorithms and data are valuable. And this lets the users, and algorithmic users for that matter, be rewarded for their participation. At the core of Blockstar is what I call creative credit. Basically a mashup of peer review and the kind of personalized recommendation system. I was kind of joking when I said I don't really know how to recommend videos. I do. How Blockstar works is that every bit of content that you consume, you have to review. Like, that is how you see more content. And if you review it positively, that's akin to sharing it. If you review it neutrally, that's just consuming it. And if you review it negatively, you hide more content from that source for yourself and for other people. So you can discover content that's shared by users to whom you give credit, as well as be introduced to users who give you credit. And on the back of Blockstar, we're also working on something called AirStar, which is a physical hardware device, an IoT. That's a smart microphone, portable and battery powered, that will do speech recognition with an FPGA hardware. So you could record yourself, but not share it until you want to. And the idea is to take this hardware platform and keep advancing it so that you can do speech synthesis and all kinds of really incredible media production stuff. And that's the basis of the open source media ecosystem that I would love to see emerge in this world. We're building Blockstar around a kind of shared history of creativity with a blockchain backend, so that we can facilitate modern interactions with intellectual property, like sampling, remixing, fan fiction, and crowdsourced creative production. all while maintaining attribution to the original creator of the work. And really, algorithms really matter. Some social platforms have been banning bots, which just doesn't really portend well for their future. So I'm building an ecosystem for generative media made with creative algorithms. That's the evolution of things. It'll be coming soon. I'm Yusuf Nathanson. Thank you. These people really helped me get this talk. And the slides are on blockstar.city if you'd like to. I have references and stuff. And I'd love to get some more questions or comments as well.
So as you can imagine, I'm very interested in the hardware aspect. So one of these days, and you had talked about this, in the future economy, if I get this device free from Flickr, I'll be able to determine which of my photos are private and which aren't, and they get to handle the ones that aren't. So Flickr will do whatever they want with my photos. They'll sum up. They could put Nike swatches on my sister's gloves, but I'll have a free cell phone. And I see some of your economies talking about that, how to monetize extremely small, high, very fine, granular intellectual property. And maybe it's photos for the Flickr phone, but maybe it's I don't know, a very small piece of data that's on this phone in a broader. Maybe Flickr's partnering with other IP companies, and we all become, customers of sensor basically. So that mechanism is going to facilitate this, because if we podcast every conversation we have at lunch, there's going to be some gold nuggets in there, and AI might be to tease those up.
Mm-hmm.
Yeah, so that'll be interesting if we can get the cost of hardware down.
Yeah.
I just wanted to say, so you mentioned like this sort of idea that you get a phone from some company, but they get to do whatever they want with some company. One of the things is there's sort of this currently accepted model of it's free, but we take your data, and sometimes difficult to really understand what data they take and how they use it, etc. What I'm thinking is, instead of having that sort of model, you have however much money they're making off the data, if instead they take that service and they charge that amount for that service, however much they're making, they charge that'll be the price of that service. But they also can buy data from you. You can sell them data. Whatever, how large market works. Adverse selection. It only works some of the things. Right? Like, we're going to sell data.
Yeah, from my perspective, I don't see a market emerging for tiny bits of data, because how valuable is like one photo or like 50 photos? It depends on what the photos are of. If it's a photo of a famous person, or